Okay, Mrs. Weethy back for video lesson 3 on the effects of the intermolecular forces. Let's get started. One of the effects on intermolecular forces is on the physical state. So the more intermolecular forces that you have that exist between molecules, the stronger the forces are, the more likely the substance will be a solid. Substances that have very weak or no intermolecular forces will be gases. So consider the relationship between intermolecular forces and physical states as we see below. A gas will have very low or negligible intermolecular forces. Liquids will have intermediate intermolecular forces, and solids will have very high, very strong. The space between gas molecules has the most, where solids have the least amount of space because those intermolecular forces are so strong. It pulls those solid particles or the atoms that make up the solid very close together. So some important relationships that we need to consider is that lowering the temperature or an increase in the pressure is going to decrease the space between molecules, and that is going to result in an increase in the intermolecular bonding. So these conditions tend to form solids and liquids. If you have an increase in temperature or a decrease in the pressure, and think about this, an increase in the temperature, your particles are going to speed up, they're going to move further and further apart. If you have a decrease in pressure, and pressure is the collisions that you have on the sides of a container, let's say. So if you decrease the pressure, those particles are going to again move further and further apart. So it increases the space between the molecules. That's going to result in a decrease in the intermolecular bonding, and that results in the formation of gases. So the intermolecular forces will affect the physical states of matter. Now, the intermolecular forces also influence the melting points and the boiling points. So the stronger the intermolecular forces you have, the higher the melting and the boiling points will be, because it takes more and more energy to break the intermolecular forces between the molecules. A comparison of melting points of 3 materials we can see in this table below. So we see that the strongest intermolecular force, or the strength of the intermolecular force, methane has London dispersion forces. We can see that its melting point is -182, so a very, very low melting point. Where acetone has dipole forces, so that's an intermediate force, and its melting point is -95 degrees Celsius, still very low, but much higher than that of methane. And then water, we can see, is kind of cut off here, but water involves hydrogen bonding, very strong, and its melting point is 0 degrees Celsius. So again, much higher than the dipole, and incredibly high compared to that of methane, the London dispersion forces. Okay, and so a review of the states of matter, we can see the motion of the particles. The gases are free to move. The liquids, they slide past one another so that they can flow, and the solids are fixed in position. Volume, gases have an indefinite volume. They take on the shape of their container. Liquids have a definite volume where the particles cannot freely spread out, and the liquids also assume the shape of its container. The solids have definite volume and have definite shape because they're fixed in a position because of their strong intermolecular forces. Gases have a very low density, liquids are higher, and solids have the highest. And if we take a look at compressibility, how easy it is to push those particles together. Gases can be compressed very easily. Liquids, they can be compressed, but because there's so little empty space, it's hard to compress them. And solids cannot be compressed at all. So with that, I'm going to leave you with be happy, have fun, and dance. This is Mrs. Weethy. So long for now.